Okay, Assalamualaikum and selamat sejahtera. Today I would like to present about my final year project. First of all, my name is Sazrol bin Suboh. My metric number is D0217100048. I am from section 2/1 students, FKEKK faculty. My supervisor name for this final year project is Mr. Adi bin Muhammad Khafi. Okay, my title for my final year project is Automatic Garden Watering System with Homemade Soil Moisture Sensor. Okay. Overview. For first, introduction. Second is problem statement. Third is objective. Fourth is methodology. Fifth is component. 6 is circuit and operation of block diagram. 7 is application. 8 is environment and sustainability. 9 is marketability, and 10 is conclusion. Okay, first, introduction. In the world of advanced electronics, life of human being should be simple. Hence, to make life more simple and convenient, I already made this automatic garden watering system. A product of controlling irrigation will help a million of people because nowadays so many people love to plant a plant. This product is using homemade soil moisture sensor with the Arduino Uno as a microcontroller. Problem statement. Problem statement is there are many plants die because of not having enough water. Some of the people work more than X hours every day. Their plant not get enough water on time. For people who live in the city, normally their plants plant the plant inside their house in the pot. So if the plant in the pot, they all usually not get enough water and not get enough water on time. Regular watering of plant also can cause wastage of water. Plants need water not every time. So with this system, it will control when the plant want the water. So automatically the motor will flow the water into the pot, so the plant will get water on time. Okay. Objective to make this project is to make sure plant will get enough water every time, even the owner not around, either they are going to work or travel. Second, to help working people who love plants the plant. Third, to save water and reduce human intervention in the process of taking care of the plant. Because by using this system, using this product, human or us will no need to take good care the plants, because every time the moisture of the soil is become lower, this system will allow the water to flow into the pot on time. Okay, methodology. Okay, research and development a circuit for automatic garden watering system by refer at the data sheet on every part and the component like water pump and others, because some of the component I'll never use before, so I need to refer the lab sheet or data sheet to know about the details of the component. I also refer to the data sheet for the Arduino Uno to get more details about the connection, because Arduino Uno have more than 10, I guess, input and output, so I need to refer the data sheet to make sure which port I must use. Okay, the next is component. Okay, here is the main component, not fully component. Main component such as Arduino Uno, homemade soil moisture sensor, water pump, relay, breadboard and jumper wire. Okay, first is Arduino Uno. Here is Arduino Uno with their picture. The cable also there. The second one is homemade soil moisture sensor. Okay, here. As you can see in the picture, the homemade soil moisture sensor, I'm using 2 nails, 1 cap of bottle, and 2 wire. Next is the water pump. Okay, here is water pump. Water pump, I'm using 12 volt power supply to power up this motor or water pump. Negative part and positive part is behind this. Next is relay. Okay, relay is to control turn on and off of the motor as set in the Arduino. Okay, next I'm using the breadboard and the jumper wire to connect all this component in one complete circuit. Okay, next operation of block diagram. Okay, here from the homemade soil moisture sensor and another prop such as wire, I'm connected to the sensor circuit. From the sensor circuit, I'm connect to the Arduino Uno. From the Arduino Uno, I connect into the transistor as the output, and from the transistor, I'm connect to the water pump to the last output, which means water pump will control the flow of water. So the input part is the homemade sensor and the probe, which means the sensor circuit, and the output part is the transistor direct to the water pump to control the water flow. Okay, next is my circuit diagram. Okay, here is my circuit diagram. I'm using 12 DC ground and Arduino Uno, probe moisture sensor, and the resistor, transistor, and by the way, solenoid valve is same for the water pump. Okay, next application of this project: automated watering the plants. Second, control irrigation system in our garden or pot in user house. Third is reducing wastage of water every day. Okay, next is environment and sustainability. Okay, this product is reliable and precise to take good care of our plants. This system does not empower with plugging model, which means it gives an extra benefit. So the third is this product also not produce any danger gas or the liquid, so it will good to the surrounding and also good to the plant. Okay, marketability. Okay, for the marketability, this product will get high demand because many people have interest in growing plant. Yeah, in the city also, there are many people who love plants in their house. Next, this product also will give really excellent benefit to the user. This product also will saving water usage every day. Okay. As a conclusion, by using of this product, we can reduce water consumption. Also, we can reduce human intervention in the process of taking care of their plant. And the last, hence will give great saving of irrigation water, stronger and healthy plant. Okay, that's all for my presentation on this slide. Thank you and Assalamualaikum. Assalamualaikum and selamat sejahtera. Today I would like to present my final year project. My final year project title is Automatic Garden Watering System by using Homemade Soil Moisture Sensor. Homemade soil moisture sensor. Here is my homemade soil moisture sensor. I'm using 2 nails, 1 cap of bottle, 2 wire to connect to the breadboard. If you want to detail about this soil moisture sensor, I already put inside my in my fully report. Okay, I will start by introducing to all my components. Here, I'm using 12 volt motor DC. I'm also using 12 volt battery to power up this motor. I'm also using relay to my motor to control on and off. I also using Arduino Uno as my microcontroller, and I also using breadboard and jumper wire to connect Arduino Uno, relay, battery and motor. I'm also using component, transistor and the resistor. For the Arduino, I'm using 12 volt power supply, which means here I'm using my power bank, output 12 volt DC and 2.1 ampere. For motor, I'm using tank below this 1.5 liter, which means normally is can use for 1 day and above. Depends on the temperature, surrounding temperature. Okay, I will start my demonstration. Before that, I will explain. Soil moisture sensor will detect moisture of the soil. Is it high or low? That's the function. If the moisture of the soil is high, Arduino will tell the motor do not turn on the water flow into the pot because the moisture of the soil is already high. But if the moisture of the soil is low, Arduino Uno will tell the motor to open and turn on to flow the water into this pot to make the soil moisture become high. Okay, when I'm plug in this cable into the power supply, automatic motor will run around 5 seconds fill the water into this pot, and then I will put this soil moisture sensor into this pot to detect either the water is enough or not, to detect the soil moisture sensor. If the moisture of the soil is already high, then after 30 seconds, the motor will not turn on because already the soil moisture is already high. Okay, I will show you. Now, I will plug in the power supply. Okay, as you can see, the motor is running, the water flow into this pot for the 5 seconds. Okay, now, this pot is already full of water. Then, I will put soil moisture sensor inside this pot to detect either the soil moisture is high or low. Okay, we will waiting for 30 seconds. If the moisture of the soil is still low, motor will run and water will flow into this pot. Okay, we will see what I mean just now. You can see if either the motor if running, this LED will turn on. Okay, we will waiting. Okay, it's already around 30 seconds. I'm sure this soil moisture sensor already detect this soil moisture is high. So, the Arduino not allow the motor to turn on to fill the water into this pot. Okay. Example, if around 1 hour or above, this moisture of soil is already low. Okay, I will put out this soil moisture sensor. Okay, as you can see, I pull out. It already detect this this moisture sensor moisture of the soil is become low, so the water will flow. Okay, we will waiting. If this soil moisture sensor did not detect the water, which means if inside the soil, the motor will running up. Okay, we're waiting. Okay, you can see motor is running because this moisture sensor not detect any water. So if I put it inside the spot again, which means already full of water, so the moisture of the soil is high. So after 30 seconds, this motor will not flow, do not turn on to flow the water inside the spot. So after around maybe 1 hour, 2 hours, the water already flowed outside from the pot. So the water, the soil moisture sensor will detect the moisture will become lower again. So it will tell Arduino to turn on this motor to flow the water into the spot again, and this what we call this system will continuously as long the power supply of the Arduino and the motor still connect and not have any problem in this circuit. Okay, for any details, I will explain inside the slide, and I will put into my report. Before I forget, I will explain the relay. For this circuit, I'm using input. My input is soil moisture sensor. For the output, I put this motor as my output. I'm using what we call digital 9 for the what we call it for the output lead. For the input I'm using analog A0. Okay, that's all for today. Thank you and assalamualaikum.